Unsolved problems come and go. In 1960, it was asked whether you could take a Venn diagram and you could rotate it and end up with the same Venn diagram. The answer is yes. Here's an example. But for what numbers is that possible? Here we have a Venn diagram made of 5 ellipses. And can we rotate it? Yes, we can. So 5 works and 3 works. 7 also works. And it turns out that in 2004, it was proved that any prime number is possible, and it has to be a prime number. Isn't it beautiful? Unsolved problems belong in the classroom. They belong there because they engage a full spectrum of student ability. The lower students can be working on skill acquisition. The upper students can be fully engaged because nobody has solved these problems. The problems can also be used for kids with math phobia. You can tell them, your bright peers aren't going to solve this. I have no idea how to solve it. Yeah, just tinker. You remove the stigma of failure because as soon as you're dealing with an unsolved problem, your chance of anyone succeeding is 0, practically. So it's a fantastic way to remove the stigma of failure in the math classroom. Lastly, you want to have these problems in the math classroom because they're like Everest. You've got to climb them because they're there. The people that attended this conference, first of all, here's the venue. This is the Banff International Research Station. And here are the people. You can imagine that we did not agree on everything all of the time. One of the things that we disagreed with most vehemently was the question of $1 million reward for these problems. The prize money to be split between the person who solves the problem and their most inspirational K-12 teacher. Some believed that that prize money was the best way to get these problems worldwide into every classroom. Others believed that this prize money was just going to be a distraction and that these problems were going to spread naturally through social media.